Welcome to Afro Think Tank University. Today's lesson is about to begin, so get ready to learn something new. Let's dive in. Welcome back to Afro Think Tank University, where today's curiosity becomes tomorrow's innovation. The world is changing faster than at any other time in human history. Artificial intelligence is writing code, robots are assembling products, self-driving machines are being tested, and automation is transforming industries across the globe. Many of the careers that exist today will evolve, while entirely new careers are emerging that didn't even exist a generation ago. So, what should today's students study if they want to help build the future instead of simply watching it happen? In today's lesson, Amari and Zuri will explore some of the most exciting careers expected to play important roles in the decades ahead. These careers share one thing in common. They involve designing, building, improving, and working with the technology shaping tomorrow's world. No one can predict the future with certainty, but one thing is clear: curiosity, education, creativity, and problem-solving will continue to matter. Class is now in session. Dialogue. Amari, Zuri, have you ever wondered what jobs will exist when we're adults? Not just the jobs people have today, but the careers that will shape the world 20 or 30 years from now? Zuri, I think about that all the time. Technology is moving incredibly fast. Artificial intelligence is becoming more capable. Robots are performing more complex tasks. Computers are becoming smarter every year. The world our generation grows into may look very different from the world we were born into. Amari, some people hear that and become nervous. They worry that robots and AI will replace every job. Zuri, technology has always changed the kinds of work people do. Throughout history, new inventions replace some tasks while also creating entirely new industries and careers. AI and robotics are likely to continue changing how many jobs are done, but exactly how the future unfolds is something no one knows for certain. Amari, so instead of asking, how do I compete against AI? Maybe we should ask, how do I become one of the people who builds AI? Zuri, exactly. Think about it. Every robot has to be designed by engineers. Every AI system has to be created by programmers and researchers. Every computer chip has to be designed and manufactured. Every new medical technology has to be invented, tested, and improved by teams of scientists, engineers, doctors, and technicians. Amari, that means the future won't only need people who use technology, it will need people who create it. Zuri, exactly. That's why today's lesson is so important. We're going to explore some of the careers that many experts believe could remain in high demand because they're focused on advancing technology, solving complex problems, and improving people's lives. Amari, and maybe one of those careers is waiting for someone watching this lesson right now. Zuri, let's find out together. Class, welcome to the jobs of the future. Technology has always changed the way people live and work. Thousands of years ago, humans invented the wheel. Later came the printing press, the steam engine, electricity, airplanes, computers, and the internet. Each invention transformed society, replacing some kinds of work while creating entirely new opportunities. Today, we are entering another period of rapid technological change. Artificial intelligence, robotics, automation, advanced manufacturing, biotechnology, and quantum computing are opening doors to discoveries that once seemed impossible. No one knows exactly what the workforce will look like 20 years from now. However, history shows that people who understand new technologies and continue learning are often well positioned to adapt to change. That is why today's students are not simply preparing for today's jobs, they are preparing for jobs that are still being invented. Dialogue. Amari, Zuri, something just occurred to me. People sometimes talk about AI and robots like they're coming to take over every job. But that's not really the whole story, is it? Zuri, not at all. Throughout history, new technologies have changed how work is done. For example, tractors transformed farming, computers changed offices, the internet created careers that didn't even exist a few decades ago, like app developers, cybersecurity analysts, cloud engineers, and social media managers. Technology often changes jobs, and it can also create new ones. Amari, so instead of asking, what jobs will disappear? Maybe we should also ask, what brand new careers are being created? Zuri, exactly. Think about artificial intelligence. Someone has to design it. Someone has to train it. Someone has to improve it. Someone has to make sure it's safe, reliable, and used responsibly. Those are careers that continue growing as technology advances. Amari, the same thing is true for robots. Robots don't build themselves. Engineers have to design them. Programmers have to write the software. Technicians have to test them. Manufacturers have to build them. People have to maintain and repair them. Zuri, exactly. And then there are people creating the computer chips inside those robots. Scientists developing stronger materials. Cybersecurity experts protecting computer systems. Biomedical engineers designing life-saving medical devices. Every new technology creates opportunities for people with the right skills. Amari, so the future belongs to people who keep learning instead of being afraid of change. Zuri, that's a great way to think about it. Change can feel uncomfortable, but it also creates opportunity. The students who stay curious, learn mathematics, study science, practice programming, build projects, and develop problem-solving skills will have many exciting paths to explore as technology continues evolving. Amari, that means our education isn't just preparing us for our first job, it's preparing us to keep learning throughout our entire lives. Zuri, exactly. The world will continue changing. The people who continue learning will be ready to grow with it, and that's one of the greatest advantages anyone can have. Imagine designing a machine that can explore Mars, assist a surgeon during a delicate operation, inspect the bottom of the ocean, harvest crops on a farm, or help firefighters search dangerous buildings after an earthquake. These are just a few examples of what robotics engineers are working on today. Robotics engineering combines several fields, including mechanical engineering, electrical engineering, computer programming, artificial intelligence, mathematics, and electronics. Every robot is designed for a purpose, and every purpose begins with a human problem that needs solving. As robots become more capable, robotics engineers will continue finding new ways for machines to perform tasks that are dangerous, repetitive, or require incredible precision, while people remain responsible for designing, supervising, improving, and deciding how these technologies are used. Dialogue. Amari, now this is the career I've been waiting to learn about. Robotics engineering! Just hearing the name sounds exciting. Zuri, it really is. Robotics engineers are some of the people responsible for designing, building, programming, testing, and improving robots that perform useful tasks in the real world. But here's something many people don't realize. Building a robot isn't just about putting metal parts together. It's about combining many different areas of science and engineering into one intelligent machine. Amari, so a robotics engineer has to understand much more than just robots? Zuri, exactly. They study mechanics so the robot can move, electrical engineering so it has power, computer programming so it knows what to do, artificial intelligence so it can make decisions in certain situations, sensors and cameras so it can understand its surroundings, and mathematics because math helps make all of those systems work together. Amari, that's incredible. It's almost like building an entire team inside one machine. Zuri, that's a great way to think about it. Every robot is made from many systems working together. If just one important system fails, the entire robot may stop working. That's why robotics engineers spend countless hours designing, testing, improving, and testing again. Amari, where do we actually see robots today? Most people probably imagine science fiction movies. Zuri, they're already everywhere. Factories use robotic arms to build products with incredible precision. Hospitals use robotic systems to assist surgeons during certain procedures. Warehouses use robots to move inventory. Farmers are beginning to use robotic technology to monitor crops and improve efficiency. Scientists send robots into space because some places are too dangerous for humans. Researchers also use underwater robots to explore parts of the ocean that people cannot easily reach. Amari, so robots aren't replacing human imagination. They're extending what humans are capable of doing. Zuri, exactly. Robots are tools. People design them. People improve them. People decide how to use them responsibly. That's why robotics engineers remain so important. Amari, you know what excites me the most? Some student watching this episode today could become the engineer who builds the next Mars rover, the next medical robot, or the next rescue robot that saves lives after a natural disaster. Zuri, that's exactly why robotics engineering is considered one of the most exciting careers for the future. Every new challenge humanity faces creates another opportunity for engineers to invent a better solution. Amari, Now we're talking about something almost everyone has heard of, artificial intelligence. But I think a lot of people hear the words AI without really understanding what they mean. Zuri, I agree. Artificial intelligence isn't just one machine or one computer. It's a field of science and engineering focused on creating computer systems that can perform certain tasks that usually require human intelligence, such as recognizing patterns, understanding language, making predictions, or helping solve complex problems. Amari, and machine learning is part of AI, right? Zuri, exactly. Machine learning is one approach that allows computers to improve at certain tasks by learning from examples and data instead of following only fixed instructions for every situation. The better the data, the better the training, the better the system can become at the task it was designed to perform. Amari, that's amazing. So when I use a search engine, or ask a digital assistant a question, or get movie recommendations, or use language translation, AI may be helping behind the scenes? Zuri, exactly. Many people use AI every day without even realizing it. Doctors use AI to help analyze certain medical images. Scientists use AI to examine enormous amounts of research data. Engineers use AI to improve robots. Businesses use AI to recognize patterns that help them make better decisions. Researchers even use AI to help discover new medicines faster. Amari, but somebody has to build all of those systems. Zuri, that's where AI engineers and machine learning specialists come in. They write computer programs, develop mathematical models, train AI systems, test them carefully, improve their accuracy, and work to reduce mistakes and bias. Responsible AI development is just as important as making AI powerful. Amari, so AI engineers don't spend their time trying to replace human intelligence. They're trying to create tools that help people solve problems more efficiently. Zuri, exactly. The best AI is designed to assist people. Human creativity, human judgment, human ethics, and human responsibility remain essential. AI is a powerful tool, but people decide how to build it and how to use it. Amari, I think that's what makes this career so exciting. You're not just writing computer code. You could be helping doctors save lives, helping scientists discover new medicines, helping engineers build safer machines, or creating technology that improves millions of lives. Zuri, that's why artificial intelligence and machine learning are considered two of the most exciting technology careers of the future. The opportunities are enormous, and we're only beginning to discover what's possible. Every robot, smartphone, satellite, medical scanner, game console, self-driving vehicle, and artificial intelligence system depends on something most people never see: the hardware. Computer engineers are the people who design the processors, electronic circuits, sensors, memory systems, communication devices, and embedded computers that make modern technology possible. While software tells a machine what to do, the hardware gives it the ability to do it. Without computer engineers, artificial intelligence couldn't process information, robots couldn't move, and billions of electronic devices used every day simply wouldn't exist. As technology continues advancing, computer engineering is expected to remain one of the foundational careers behind innovation. Dialogue. Amari, I think I finally understand something. When people hear the word computer, they usually think about the screen. But somebody had to build everything inside the computer first. Zuri, exactly. That's what computer engineers do. They design the physical hardware that allows computers and electronic devices to function. Every processor, every memory chip, every circuit board, every sensor, every communication system has to be carefully designed before software can ever run on it. Amari, so software engineers write programs, but computer engineers build the machines those programs run on? Zuri, exactly. The two careers work together. Think of it this way. Software is like the instructions for a recipe. The hardware is the kitchen where those instructions are carried out. Without the kitchen, the recipe can't become a meal. Amari, that makes perfect sense. And these tiny computer chips are inside almost everything now, not just laptops and phones. Zuri, that's right. Computer engineers help build the technology inside. Smartphones, tablets, medical equipment, airplanes, cars, industrial robots, spacecraft, satellites, smart appliances, security systems, and even modern farming equipment. Many everyday devices contain small computers called embedded systems that quietly perform important jobs. Amari, so even a modern refrigerator, or a washing machine, may contain a computer designed by computer engineers? Zuri, exactly. As more products become smart, Computer engineers are designing the electronics that help those products communicate, collect information, and operate more efficiently. The demand for reliable hardware continues to grow as technology expands into more areas of life. Amari, and I guess AI wouldn't work without powerful computer hardware. Zuri, exactly. Artificial intelligence requires enormous computing power. Computer engineers design faster processors, more efficient chips, better memory systems, and specialized hardware that helps AI perform complex calculations quickly. Without those advances in hardware, many modern AI systems wouldn't be practical. Amari, so while everyone talks about artificial intelligence, there are computer engineers working behind the scenes making it all possible. Zuri, exactly. Many of the world's biggest technological breakthroughs begin with better hardware, faster computers, smarter chips, more efficient electronics. Every improvement creates new possibilities for scientists, engineers, doctors, businesses, and everyday people. Amari, that's amazing. Computer engineers aren't just building computers. They're building the foundation that supports nearly every modern technology we use. Zuri, and that's why computer engineering is considered one of the most exciting and influential careers of the future. When you build the hardware, you help build tomorrow. Take a moment to look around your home. The lights, the television, the refrigerator, your phone charger, the internet, traffic lights, hospitals, airports, factories, electric cars, wind turbines, solar farms. Every one of these technologies depends on electricity. Electrical engineers are the people who design the systems that generate, control, store, and deliver electrical power safely and efficiently. They also create many of the electronic systems that make robots, computers, satellites, communication networks, and modern transportation possible. As the world becomes more connected and increasingly powered by electricity, electrical engineering is expected to remain one of the most important careers of the future. Dialogue. Amari, wow. I don't think people realize just how much of our world depends on electricity. Almost everything around us uses it. Zuri, that's exactly why electrical engineering is so important. Electrical engineers don't just work with power lines. They design and improve the systems that allow electricity to safely reach our homes, schools, hospitals, businesses, and entire cities. Without them, much of modern life would come to a stop. Amari, so when I flip a light switch, charge my phone, or turn on my computer, there's a good chance an electrical engineer helped make that possible? Zuri, exactly. Electrical engineers work on power grids, electric motors, electronic circuits, communication systems, renewable energy, medical equipment, satellites, and even the batteries that power electric vehicles. Their work reaches almost every industry you can imagine. Amari, I never realized electricity connects so many different careers. Zuri, it does. Think about robotics. Robots need electric motors to move. Think about artificial intelligence. AI computers need electricity to operate. Think about hospitals. Life-saving medical equipment depends on reliable electrical systems. Even spacecraft and satellites rely on electrical engineers to design systems that can survive the harsh environment of space. Amari, and as more people drive electric cars, use solar panels, and rely on renewable energy, electrical engineers become even more important. Zuri, exactly. One of the fastest growing areas of electrical engineering is developing cleaner and more efficient ways to produce, store, and distribute electricity. Engineers are improving batteries, designing smarter electrical grids, building renewable energy systems, and helping communities use energy more efficiently. Amari, so electrical engineers aren't just powering today's world, they're helping build tomorrow's world too. Zuri, that's right. Every breakthrough in clean energy, every improvement in communication, every advancement in robotics, and every smarter electrical system creates new opportunities for electrical engineers to make life better for millions of people. Amari, I think I'm beginning to notice a pattern. Every future career we've talked about so far, robotics, artificial intelligence, computer engineering, and now electrical engineering, they all work together. Zuri, exactly. The future won't be built by one profession working alone. It will be built by teams of engineers, scientists, programmers, researchers, and inventors working together to solve humanity's biggest challenges. Amari, and that makes electrical engineering one of the most exciting careers anyone could choose. Because when you help power the world, you help power the future. Every time you open a website, send a text message, watch a video, play a game, use a navigation app, or ask an AI assistant a question, you're interacting with computer science. Computer scientists create the software, algorithms, operating systems, databases, cloud platforms, and digital tools that power much of our modern world. They solve problems by designing logical solutions and turning those solutions into computer programs. As artificial intelligence, robotics, cybersecurity, and cloud computing continue to expand, computer science is expected to remain one of the most versatile and influential fields for students who enjoy solving problems with technology. Dialogue. Amari, Zuri, we've already talked about robots, AI, computer engineers, and electrical engineers. So where does computer science fit into all of this? Zuri, computer science is like the language that brings technology to life. Computer scientists design the software that tells computers what to do. Without software, a computer is just electronic hardware waiting for instructions. Amari, so when I open an app, visit a website, or play a video game, somebody had to write all of that code? Zuri, exactly. Computer scientists and software engineers create operating systems, mobile apps, video games, search engines, artificial intelligence programs, cloud computing platforms, banking software, medical systems, and millions of other digital tools people use every day. Amari, that sounds like one of the most creative careers we've learned about so far. You're building something that didn't exist before. Zuri, that's one of the best parts of computer science. You start with an idea, then you solve one problem at a time until your idea becomes a real program that people can use. It combines creativity with logic. Amari, so what skills would someone need if they wanted to become a computer scientist? Zuri, strong problem-solving skills are very important. Programming languages like Python, Java, C++, or JavaScript are useful tools. Mathematics helps in many areas, but just as important are curiosity, patience, teamwork, and the willingness to keep learning because technology changes constantly. Amari, and I guess AI programmers are computer scientists too? Zuri, many of them are. Computer science opens the door to many different specialties. Someone might become an AI engineer, a software developer, a game designer, a cybersecurity expert, a cloud architect, a data scientist, or even start their own technology company. Amari, wow. That means one degree can lead to many different careers. Zuri, exactly. That's one reason computer science continues to attract students around the world. It gives you a strong foundation that can be applied in almost every industry: healthcare, education, space exploration, finance, entertainment, manufacturing, agriculture. Nearly every field now depends on computer software. Amari, the more we learn, the more I realize something. Technology isn't replacing human creativity. It's creating new ways for creative people to solve problems. Zuri, exactly. The future will always need people who can imagine new ideas, and then turn those ideas into reality. That's exactly what computer scientists do every day. Imagine waking up one morning and discovering that a hospital's computers no longer work, or a city's power grid has been disrupted, or millions of people's personal information has been stolen from a company. As our world becomes more connected, protecting computers, networks, and digital information becomes more important every year. That's where cybersecurity professionals come in. Cybersecurity experts defend computer systems against criminals, protect sensitive information, discover security weaknesses before they can be exploited, and help keep hospitals, businesses, governments, schools, and everyday families safe online. As AI, cloud computing, and connected devices continue to expand, cybersecurity is expected to remain one of the fastest-growing technology careers in the world. Dialogue. Amari, everything we've talked about so far depends on computers, robots, artificial intelligence, phones, banks, hospitals, even traffic lights. But what happens if someone tries to break into those systems? Zuri, that's exactly why cybersecurity exists. Cybersecurity professionals are the digital defenders of our modern world. Their job is to protect computer systems, networks, and important information from cyber criminals who try to steal data, damage systems, or interrupt important services. Amari, so they're kind of like detectives and security guards, except they're protecting computers instead of buildings? Zuri, that's a great comparison. Some cybersecurity experts search for weaknesses before criminals find them. Others monitor computer networks for suspicious activity. Some investigate cyber attacks after they happen. Others design stronger security systems to stop attacks before they even begin. Amari, I never realized how many things depend on cybersecurity. If hospitals were attacked, patients could be affected. If banks were attacked, people's money could be at risk. If power companies were attacked, entire communities could lose electricity. Zuri, exactly. That's why cybersecurity isn't only about protecting computers, it's about protecting people. Every secure system helps families, businesses, schools, hospitals, and governments operate more safely. Amari, and I bet AI is changing cybersecurity too. Zuri, it is. Cybersecurity professionals are increasingly using AI to help identify unusual activity and respond to threats more quickly. At the same time, they also study how attackers might misuse AI so they can build stronger defenses. It's a field where people must keep learning because technology is always changing. Amari, so if someone enjoys solving puzzles, thinking like a detective, and using technology to help protect others, cybersecurity could be a great career. Zuri, absolutely. It combines technology, critical thinking, teamwork, and problem solving. As our digital world grows, organizations will continue needing skilled people to help keep their systems secure. Amari, I like that. Some heroes wear capes, others protect millions of people with knowledge, skill, and a computer. Zuri, exactly. Cybersecurity professionals help make sure the digital future is not only smarter, but also safer. Look at your smartphone, your computer, your television, a modern automobile, a satellite orbiting Earth, a hospital MRI machine, a robot working in a factory. What do all of these incredible technologies have in common? Inside each one are tiny electronic chips called semiconductors. Semiconductors are the foundation of the digital world. They process information, store data, control machines, and power artificial intelligence. Without them, modern electronics as we know them simply would not exist. Semiconductor engineers design, manufacture, test, and improve these tiny chips. Although they are often smaller than a fingernail, they contain billions of microscopic transistors working together at incredible speeds. As demand for AI, robotics, electric vehicles, medical technology, and advanced computing continues to grow, semiconductor engineering is expected to remain one of the world's most important technology careers. Dialogue. Amari, wow. It's hard to believe something so tiny could be so important. These little chips are inside almost everything we use every day. Zuri, that's exactly why semiconductor engineering is such an exciting career. Most people never see these chips, but they make modern technology possible. Every smartphone, every laptop, every AI supercomputer, every robot, every satellite, every modern vehicle depends on semiconductor technology. Amari, so when people talk about powerful computers, they're really talking about incredibly powerful computer chips. Zuri, exactly. The faster and more efficient those chips become, the faster computers can solve problems. The more advanced AI systems can become, the smarter robots can operate, and the more amazing new technologies engineers can create. Amari, how do engineers even make something that small? It sounds almost impossible. Zuri, it takes years of education and incredible precision. Semiconductor engineers use advanced science, chemistry, physics, materials science, computer engineering, and highly specialized manufacturing equipment to build chips with microscopic features. Some modern chips contain billions of tiny transistors working together. That's one reason they're considered one of the greatest engineering achievements in history. Amari, so these engineers aren't just making computer parts. They're building the foundation that almost every modern technology depends on. Zuri, exactly. Without semiconductor engineers, artificial intelligence couldn't process information quickly. Modern medical equipment couldn't perform many of the tasks doctors rely on. Electric vehicles wouldn't function the way they do today. Spacecraft and satellites couldn't perform complex missions. Even many household appliances wouldn't be nearly as smart or efficient. Amari, I remember hearing about shortages of computer chips a few years ago. Didn't that affect lots of industries? Zuri, it did. Because so many products rely on semiconductors, shortages showed the world just how essential these tiny chips are. That's one reason many countries and companies continue investing in semiconductor research and manufacturing. Amari, so this career isn't only about making smaller chips, it's about helping build the future of technology itself. Zuri, exactly. Every generation of better chips creates opportunities for better robots, smarter AI, safer medical devices, more efficient transportation, and discoveries we haven't even imagined yet. Amari, it's amazing. Some of the biggest innovations in history begin with something almost too small to see. Every second of every day, people create enormous amounts of information called data. Every online search, every weather report, every hospital record, every GPS location, every scientific experiment, every space mission, every business transaction creates data. By itself, data is simply information. But when skilled professionals organize, study, and analyze that information, it becomes knowledge that helps people make better decisions. That's what data scientists do. They use mathematics, statistics, programming, and artificial intelligence to discover patterns that help improve healthcare, transportation, education, business, environmental protection, and scientific research. As the world continues generating more information than ever before, data science is expected to remain one of the most valuable careers of the future. Dialogue. Amari, wow, I had no idea we create so much data every single day. It seems like almost everything we do leaves behind information. Zuri, that's exactly right. Think about it. Every time you check the weather, use a GPS, visit a website, watch a video, buy something online, or even exercise with a fitness tracker, new data is being created. The challenge isn't collecting information anymore. The challenge is understanding it. Amari, so that's where data scientists come in? Zuri, exactly. Data scientists organize huge amounts of information and look for meaningful patterns. They ask questions like, what do these numbers tell us? Why is this happening? What can we learn from this information? Those answers help people make smarter decisions. Amari, can you give me an example? Zuri, of course. Doctors can study patient data to look for patterns that may improve treatments. Scientists can analyze climate data to better understand weather and environmental changes. Cities can use traffic data to improve transportation. Businesses can study customer data to improve products and services. Even sports teams use data to help players perform better. Amari, so data isn't just numbers, it's information that helps solve real-world problems. Zuri, exactly. And because there is so much information available today, data scientists often use computer programming, mathematics, statistics, and artificial intelligence to help analyze it more efficiently. Human judgment is still essential for asking good questions, checking results, and deciding how to use the findings responsibly. Amari, that sounds like being a detective, except instead of searching for clues at a crime scene, you're searching through millions of pieces of information looking for answers. Zuri, that's a great comparison. Every pattern they discover can help improve healthcare, protect the environment, advance scientific research, improve education, develop better AI, or even help governments and businesses make better decisions. Amari, the more careers we study, the more I notice something. Every one of them is connected. AI needs data, robots use data, engineers collect data, scientists depend on data. Everything works together. Zuri, exactly. That's why data science has become one of the most important careers of the future. Information is everywhere, but it takes skilled people to transform information into knowledge and knowledge into solutions that improve lives. Imagine helping someone walk again with a robotic prosthetic leg, helping doctors detect disease earlier with advanced medical imaging, designing an artificial heart valve, creating a robotic surgical system that allows doctors to perform incredibly precise operations, or developing a brain-computer interface that helps someone with paralysis communicate. These are just a few examples of what biomedical engineers do. Biomedical engineering combines biology, medicine, engineering, computer science, physics, and mathematics to solve medical problems and improve people's lives. As medical technology continues advancing, biomedical engineers will play an increasingly important role in helping people live longer, healthier, and more independent lives. For students who love both science and helping others, biomedical engineering offers an opportunity to combine compassion with innovation. Dialogue. Amari, I think this might be one of my favorite careers we've learned about. Biomedical engineering combines technology with helping people. That's incredible. Zuri, I agree. Biomedical engineers ask one very important question every day. How can technology improve human health? Everything they create begins with helping a patient live a better life. Amari, so they're not just inventing cool machines, they're solving real medical problems. Zuri, exactly. Some biomedical engineers design advanced prosthetic arms and legs that allow people to walk, run, and even pick up delicate objects. Others develop artificial joints, heart valves, hearing devices, or medical implants. Some improve MRI machines, CT scanners, and ultrasound systems that help doctors see inside the human body without surgery. Amari, and this connects to what we learned in our neuroscience lesson. The tiny brain probes, brain-computer interfaces, those involve biomedical engineers too. Zuri, exactly! Biomedical engineers work closely with doctors, neuroscientists, surgeons, computer scientists, robotics engineers, and AI researchers. Together, they create technologies that help people recover from injuries, manage illnesses, and sometimes restore abilities that were once thought impossible. Amari, that's amazing. It really shows how different careers work together. No one changes the world alone. Zuri, that's one of the biggest lessons in STEM. Great discoveries happen because people from different fields combine their knowledge. Medicine needs engineering. Engineering needs computer science. Computer science uses mathematics. Artificial intelligence depends on data. Everything is connected. Amari, I also imagine biomedical engineers have a huge responsibility. If they're designing equipment that doctors use on patients, it has to be incredibly safe and reliable. Zuri, absolutely. Before a new medical device reaches a hospital, it goes through years of research, testing, improvements, and safety evaluations. Biomedical engineers work carefully because people's health depends on the quality of their work. Amari, so this career isn't only about being smart, it's about being careful, patient, responsible, and always thinking about how your work affects other people's lives. Zuri, exactly. Biomedical engineering is one of the best examples of science being used to serve humanity. Every improvement they make has the potential to reduce suffering, restore independence, and give people hope. Amari, I think that's one of the greatest goals anyone could have. Using technology not just to build better machines, but to build healthier, happier lives. Imagine trying to build an airplane out of paper, or a smartphone out of wood, or a spacecraft out of ordinary glass. It wouldn't work. Every great invention depends on the right materials. That's why materials science engineering is one of the most important careers behind the scenes of modern technology. Materials scientists discover, design, test, and improve the substances used to build everything from bridges and buildings to robots, satellites, batteries, computer chips, and medical implants. They ask questions like, can we make this stronger? Can we make it lighter? Can we make it last longer? Can we make it safer for people and better for the environment? Many of tomorrow's technological breakthroughs will begin with the discovery of better materials. Dialogue. Amari, Zuri, I never really thought about what things are actually made of. I usually focus on the invention itself, not the materials inside it. Zuri, that's exactly what makes materials science engineering so fascinating. Before engineers can build the next generation of robots, electric vehicles, medical devices, or spacecraft, someone has to invent materials that are strong enough, light enough, durable enough, and safe enough to make those inventions possible. Amari, so if someone invents a battery that lasts twice as long, or a metal that's much lighter but just as strong, that could change entire industries. Zuri, exactly. Materials scientists help create better batteries for electric vehicles, stronger materials for airplanes and spacecraft, heat-resistant materials for jet engines, advanced ceramics used in electronics, special materials for computer chips, and even materials that safely interact with the human body for medical implants and prosthetic devices. Amari, that's amazing. One new material could improve thousands of different products. Zuri, that's why materials science is sometimes called a foundational science. A single discovery can help engineers across many different fields. Robotics engineers, biomedical engineers, computer engineers, electrical engineers, aerospace engineers, renewable energy engineers. They all benefit when better materials become available. Amari, I guess that's why scientists are always searching for stronger, lighter, and more efficient materials. Every improvement creates new possibilities. Zuri, exactly. Imagine batteries that charge much faster, solar panels that capture more energy, safer building materials that better withstand earthquakes and hurricanes, or lightweight materials that allow spacecraft to travel farther while using less fuel. Those breakthroughs often begin inside materials science laboratories. Amari, so these engineers don't just build better materials, they help build a better future. Zuri, that's right, every new material opens the door to inventions that were once impossible. The next medical breakthrough, the next space mission, the next generation of AI computers, or the next revolutionary robot may all begin with someone discovering a better material. Amari, I think that's incredible. Sometimes the biggest technological revolution starts with something people can barely see, a new material, a new idea, and one scientist willing to ask, what if we could make this even better? Every day, Billions of people use electricity. It powers our homes, schools, hospitals, computers, factories, and even the internet. But as the world's population grows, so does our need for energy. Renewable energy engineers are solving one of humanity's biggest challenges: how to provide reliable electricity while making better use of natural energy sources such as sunlight, wind, flowing water, geothermal heat, and ocean energy. They design solar farms, wind turbines, hydroelectric systems, battery storage technologies, and smarter electrical grids that help deliver power where it's needed. As technology continues to improve, renewable energy engineers will help create cleaner, more efficient, and more resilient energy systems for communities around the world, and perhaps one day for human settlements beyond Earth. Dialogue. Amari, every single thing around us needs electricity. Our lights, our phones, our computers, even the robots we've been talking about. Without power, none of this works. Zuri, exactly. That's why renewable energy engineers have such an important job. They're constantly asking, how can we produce enough energy for everyone while improving the technologies that generate and store it? Amari, so they don't just put up solar panels or wind turbines. They're inventing better ways to capture, store, and deliver energy. Zuri, that's right. Some engineers develop solar panels that produce more electricity from the same amount of sunlight. Others design larger, more efficient wind turbines. Some improve hydroelectric systems that use moving water to generate power. Others create advanced batteries that can store energy until people need it most. Amari, that must take a lot of teamwork. Electrical engineers, computer engineers, material scientists, they're all working together. Zuri, exactly. The future of energy depends on many different kinds of engineers solving problems together. They use mathematics, physics, chemistry, computer programming, and creativity to improve the systems millions of people rely on every day. Amari, and as cities grow, they'll need even smarter ways to deliver electricity safely and reliably. Zuri, that's why engineers are building smarter electrical grids that can respond more quickly to changing energy demands. They're also improving energy storage so electricity produced at one time can be available later when it's needed. Amari, I never realized that something as simple as turning on a light depends on thousands of engineers working behind the scenes. Zuri, it really does. Every improvement in renewable energy technology can help communities become more reliable, more efficient, and better prepared for the future. Who knows? One of today's students might design the next breakthrough battery, create a revolutionary solar technology, or invent a new way to power tomorrow's cities. Amari, now that's an exciting future. The world will always need energy, and it will always need curious people willing to imagine better ways to provide it. Think about everything that happens when you board an airplane, use the internet, visit a hospital, or watch a rocket launch. Thousands, even millions of parts must work together perfectly. A tiny mistake in one part can affect the entire system. That's where systems engineers come in. Instead of focusing on just one machine or one piece of technology, systems engineers look at the entire picture. They make sure every part works together safely, efficiently, and reliably. They help coordinate teams of engineers, programmers, scientists, designers, and technicians so that incredibly complex projects become successful. Without systems engineers, many of the world's most advanced technologies would never function as one complete system. Dialogue. Amari, wow, this is different from all the other engineering jobs we've learned about. Most engineers build one thing, but systems engineers make sure everything works together. Zuri, exactly! Imagine trying to build a spaceship. You'd have people designing the engines, others building the computers, others creating life support systems, others designing communications, and many more working on navigation, power, and safety. Someone has to make sure all of those pieces work together as one complete spacecraft. Amari, so they're like the master organizers of technology. Zuri, that's a great way to think about it. Systems engineers see the big picture. They ask questions like, will this part work with that part? What happens if something fails? Can we make the entire system safer? How can we improve performance without creating new problems? Amari, that sounds like solving one giant puzzle with thousands of moving pieces. Zuri, exactly. Every modern city is a system. Every airport is a system. Every hospital is a system. Every self-driving car, every robotics factory, even the internet itself. They're all made up of countless smaller systems working together. Amari, so if one team changes something, the systems engineer has to make sure it doesn't accidentally create problems somewhere else. Zuri, that's right. They're constantly testing, planning, communicating, and improving. They bring experts from many different fields together so everyone works toward the same goal. Amari, I think that's one of the coolest careers we've learned about. You're not just building technology, you're helping thousands of brilliant people work together to build something incredible. Zuri, and that's an important lesson beyond engineering. The biggest achievements in history rarely happen because of one person. They happen because talented people work together. Systems engineers help make that teamwork possible. Amari, so the future won't just need inventors, it will need leaders who can connect ideas, people, and technology into one amazing system. Zuri, exactly. Sometimes the greatest innovation isn't inventing one new machine, it's bringing hundreds of great ideas together to change the world. Every invention begins with an idea. But an idea alone doesn't change the world. Someone has to recognize a problem, imagine a solution, build it, improve it, and share it with others. That's what technology entrepreneurs do. Technology entrepreneurs combine creativity, engineering, business, and leadership to develop products and services that improve people's lives. Some create new software, others invent medical devices, educational tools, robotics companies, or clean energy technologies. Many of the world's most influential technology companies started with a simple question: how can we make life better? The next great invention could come from a student who is curious enough to ask that same question. Dialogue. Amari, we've learned about scientists, engineers, programmers, and inventors. But who brings all of those ideas together and turns them into something millions of people can actually use? Zuri, that's where technology entrepreneurs come in. They're builders of businesses and problem solvers. They bring together talented people, develop new ideas, test them, improve them, and introduce them to the world. Amari. So being an entrepreneur isn't just about starting a company, it's about solving real problems. Zuri, exactly! Some entrepreneurs create apps that help students learn. Some design robots that make dangerous jobs safer. Others build companies that improve healthcare, transportation, agriculture, or communication. The best entrepreneurs don't just chase success, they look for ways to make life better for others. Amari. And they don't have to invent everything themselves, do they? Zuri, not at all. Great entrepreneurs know how to build strong teams. They work with engineers, designers, scientists, programmers, marketing experts, and many other professionals. Everyone brings different skills to the table. Amari, that means leadership is just as important as creativity. Zuri, exactly. A great leader listens, learns, keeps improving, and isn't afraid to try again after a setback. Many successful companies were built after people learned from mistakes and kept moving forward. Amari, so every big technology company started with someone willing to say, I think there's a better way. Zuri, that's the spirit of innovation. Some ideas become businesses, some become life-changing inventions, some inspire other people to create something even better. Every breakthrough begins with curiosity, determination, and the courage to take the first step. Amari, that means the next company that changes the world could begin in a classroom, a garage, a library, or even in someone's imagination. Zuri, absolutely. The future belongs to people who are willing to keep learning, keep creating, and keep solving problems. Today's students aren't just preparing for tomorrow's jobs. Some of them will create the jobs of the future. When many people hear the word math, they think of homework, tests, or difficult equations. But mathematicians, scientists, and engineers see something completely different. They see a language that describes patterns, predicts outcomes, solves problems, and explains how our universe works. Every bridge ever built, every airplane that has ever flown, every smartphone, every video game, every artificial intelligence program, every robot, and every spacecraft exists because someone used mathematics to make it possible. Math isn't just about finding the right answer, it's about learning how to think logically, recognize patterns, and solve problems. Skills that will be valuable in almost every career of the future. Dialogue. Amari, you know what's funny? A lot of students ask, when am I ever going to use math? After everything we've learned, I think we finally have the answer. Zuri, we sure do. Every future career we've explored depends on mathematics. Robotics engineers use math to program movement. AI engineers use math to train intelligent computer systems. Architects use math to design safe buildings. Scientists use math to test ideas. Even doctors and medical researchers use mathematics to understand data and improve treatments. Amari, so math isn't just another school subject. It's one of the tools that makes innovation possible. Zuri, exactly. Think about launching a rocket. If the calculations are wrong, the rocket misses its destination. Think about building a bridge. If the measurements are wrong, the bridge may not be safe. Think about designing a robot. If the programming calculations are wrong, the robot won't work the way it's supposed to. Amari, that means math helps us build things we can trust. Zuri, it does. But math also teaches something even bigger. It teaches patience, careful thinking, problem solving, and how to keep trying different approaches until you find a solution. Those habits are valuable in every part of life. Amari, I never thought about math that way. It's almost like exercising your brain. The more you practice, the stronger your thinking becomes. Zuri, that's exactly right. Nobody is born knowing advanced mathematics. People improve through practice, curiosity, and persistence. Every problem you solve helps prepare your mind for bigger challenges in the future. Amari, so every equation, every graph, every measurement is helping prepare us to build tomorrow's world. Zuri, absolutely. Math is the language engineers speak. It's the language computers understand. It's the language scientists use to discover new knowledge. And it will continue to help shape the future for generations to come. Amari, from now on, whenever I see a math problem, I'll remember that I might be learning a skill that helps me design a robot, build a spacecraft, or invent something the world has never seen before. Behind almost every successful scientist, engineer, inventor, or entrepreneur is someone who believed in them. Very often, that someone was a parent, grandparent, guardian, teacher, or mentor. Children are naturally curious. They ask questions, take things apart, imagine new ideas, and wonder how the world works. When adults encourage that curiosity instead of discouraging it, they help children build confidence, resilience, and a lifelong love of learning. Supporting STEM doesn't require having all the answers. Sometimes, the most powerful thing a parent can say is, "Let's learn it together." The encouragement children receive today can inspire them to become tomorrow's innovators, engineers, doctors, scientists, and leaders. Dialogue. Amari, Zuri, we've talked about so many amazing careers, but none of them begin with a college degree. They begin much earlier. Zuri, that's right. They begin with curiosity, a child asking questions, a family encouraging them to keep learning, and adults reminding them that it's okay not to know everything as long as they never stop trying to learn. Amari, sometimes all it takes is one person believing in you. One teacher, one parent, one grandparent, one mentor. That encouragement can change an entire life. Zuri, exactly. When parents celebrate effort instead of only perfect grades, children become more confident about solving difficult problems. When parents encourage reading, building, experimenting, and asking questions, they're helping prepare their children for opportunities that may not even exist yet. Amari, that means learning doesn't stop when school ends for the day. It can happen while cooking dinner, working on a project, visiting a museum, watching the stars, or simply asking, "How does that work?" Zuri, absolutely. Some of the greatest inventors in history never stopped being curious. They kept asking questions, they kept exploring, they kept learning from mistakes. Parents can help create that same mindset at home. Amari, and children don't have to become engineers or scientists to benefit from STEM. The problem-solving skills they learn can help in almost any career. Zuri, exactly. STEM teaches people how to think clearly, work as a team, solve challenges, and keep improving. Those are life skills that never go out of style. Amari, so maybe the greatest gift a parent can give isn't having all the answers, it's helping their child believe they can find the answers. Zuri, beautifully said. Every encouraging word, every science project, every trip to the library, every conversation about how the world works, plants a seed. And one day that seed may grow into an invention, a discovery, or a breakthrough that helps millions of people. Artificial intelligence is one of the most powerful technologies ever created. It can analyze enormous amounts of information, recognize patterns, help solve complex problems, and assist people in many different kinds of work. But AI is a tool. It doesn't replace every uniquely human ability. People still imagine new ideas, build meaningful relationships, make difficult ethical decisions, inspire others, and create works of art that reflect human experiences. The future won't belong to people who compete against AI. It will belong to people who understand how to work with AI while strengthening the uniquely human qualities that technology cannot easily reproduce. Dialogue. Amari, after everything we've learned, I finally understand something. AI isn't the end of human potential. It's another tool we can use to build an even better future. Zuri, exactly! Think about it. AI can process information incredibly fast, but it doesn't dream about tomorrow the way people do. It doesn't experience life the way humans do, and it doesn't understand the meaning that people bring to their work and relationships. Amari. So our greatest advantage isn't trying to act like machines. It's becoming even better at being human. Zuri, that's right. The world will always need people who can lead others, work together as a team, communicate clearly, think creatively, solve new problems, and make thoughtful decisions when situations become difficult. Those are skills that help every profession. Amari, that explains why artists, teachers, scientists, engineers, doctors, entrepreneurs, and community leaders all depend on more than knowledge alone. They depend on imagination and good judgment. Zuri, exactly. Technology can help us calculate, but people decide what goals are worth pursuing. Technology can generate ideas, but people decide which ideas improve lives. Technology can assist, but people are responsible for how it is used. Amari, so instead of being afraid of AI, we should learn how to use it wisely. Zuri, absolutely. The students who succeed in the future will combine technical knowledge with human qualities. They'll know how to ask thoughtful questions, listen to different perspectives, adapt when challenges appear, and continue learning throughout their lives. Amari, that means every time we practice kindness, leadership, creativity, or teamwork, we're developing strengths that will always matter. Zuri, exactly. The future isn't humans versus technology. The future is humans and technology working together to solve problems that neither could solve alone. Amari, now I understand. The smartest people won't just know how to use AI. They'll know how to bring something AI can never fully replace, their humanity. Throughout this lesson, we've explored many exciting careers that will help shape tomorrow's world. Artificial intelligence, robotics, cybersecurity, biomedical engineering, renewable energy, data science, computer engineering, materials science, systems engineering, and many more. At first, these careers may seem separate, but in reality, they are deeply connected. The biggest challenges facing humanity, improving healthcare, exploring space, building smarter cities, developing new technologies, and protecting our planet, will require people from many different fields working together. The future won't be built by one profession. It will be built by teams of curious, creative people combining their talents to solve problems that no one could solve alone. Dialogue. Amari, after learning about all these careers, I finally understand something. The future isn't built by one brilliant person. It's built by thousands of people working together. Zuri, exactly. Think about building a city of the future. Architects design the buildings. Electrical engineers power them. Computer scientists write the software. Cybersecurity experts protect the networks. Renewable energy engineers provide electricity. Biomedical engineers improve healthcare. Systems engineers make sure everything works together. Every career has an important role. Amari, it's like a giant team where everyone has different talents, but they're all working toward the same goal. Zuri, that's exactly how innovation works. The greatest achievements in history weren't created by one person. They happened because people shared ideas, learned from one another, and combined their knowledge to create something greater than any one individual could build alone. Amari, that means students don't have to be exactly alike. Some people love math, some love science, some enjoy designing things, others enjoy building, leading, teaching, or solving problems. There's a place for all of those talents. Zuri, absolutely. The future needs inventors. The future needs artists. The future needs engineers. The future needs entrepreneurs. The future needs doctors. The future needs programmers. The future needs teachers. The future needs leaders. Most importantly, the future needs people who are willing to keep learning. Amari, I used to think choosing one career meant leaving everything else behind. Now I realize that every career connects with others. When people work together, amazing things become possible. Zuri, that's the biggest lesson of all. Your future isn't limited by one subject, one skill, or one dream. Keep learning, keep asking questions, keep helping others, because the future is built by people who work together. Amari, and maybe one day, we'll be part of the team that changes the world. Throughout this lesson, we've explored many exciting careers that will help shape tomorrow's world. Artificial Intelligence, Robotics, Cybersecurity, Biomedical Engineering, Renewable Energy, Data Science, Computer Engineering, Material Science, Systems Engineering, and many more. At first, these careers may seem separate, but in reality, they are deeply connected. The biggest challenges facing humanity, improving healthcare, exploring space, building smarter cities, developing new technologies, and protecting our planet, will require people from many different fields working together. The future won't be built by one profession. It will be built by teams of curious, creative people combining their talents to solve problems that no one could solve alone. Dialogue. Amari, after learning about all these careers, I finally understand something. The future isn't built by one brilliant person. It's built by thousands of people working together. Zuri, exactly. Think about building a city of the future. Architects design the buildings. Electrical engineers power them. Computer scientists write the software. Cybersecurity experts protect the networks. Renewable energy engineers provide electricity. Biomedical engineers improve healthcare. Systems engineers make sure everything works together. Every career has an important role. Amari, it's like a giant team where everyone has different talents, but they're all working toward the same goal. Zuri, that's exactly how innovation works. The greatest achievements in history weren't created by one person. They happened because people shared ideas, learned from one another, and combined their knowledge to create something greater than any one individual could build alone. Amari, that means students don't have to be exactly alike. Some people love math, some love science, some enjoy designing things, others enjoy building, leading, teaching, or solving problems. There's a place for all of those talents. Zuri, absolutely. The future needs inventors. The future needs artists. The future needs engineers. The future needs entrepreneurs. The future needs doctors. The future needs programmers. The future needs teachers. The future needs leaders. Most importantly, the future needs people who are willing to keep learning. Amari, I used to think choosing one career meant leaving everything else behind. Now I realize that every career connects with others. When people work together, amazing things become possible. Zuri, that's the biggest lesson of all. Your future isn't limited by one subject, one skill, or one dream. Keep learning, keep asking questions, keep helping others, because the future is built by people who work together. Amari, and maybe one day, we'll be part of the team that changes the world. Thanks for learning with Afro Think Tank University. Keep thinking, keep asking questions, and we'll see you in the next lesson.